Now that you know how to solve systems of equations by graphing and by the method of elimination, I'm going to go over one more method that you can use for systems, which is the algebraic method of substitution. So this method is pretty much what it sounds like. You substitute something and solve for x and solve for y, either direction. So you may use substitution method when you have an isolated variable. When I say isolated variable, I mean you have x equals a number y plus another number, or you have y equals a number with x plus another number. So these are the two cases where you would want to use substitution. You can always use it when they're not like this, but then you'd have to go ahead and solve for x or y on your own, which is just a method you would want to use if it's convenient. So the idea is we're going to be substituting an expression rather than a number into a variable. So here's the general process right here. So you want to use it when x or y are by themselves in one or both of the equations. And you're going to substitute that expression, what comes after the equal sign, into the other equation. That's going to give you a new equation you're going to solve for either x or y. And once you have x or y, you do what we've done before. You plug it back into the first or second equation, it doesn't matter, and solve for the other variable. So let's go ahead and see what this looks like. So we have two examples. So first example we have is the following. We have both equations solved for y. So I'm going to be substituting the y expression from one equation into the y of the other equation. So I'm pretty much setting these two equations equal to each other because they're both solved for y. So I'm going to replace the y I highlighted in green for the expression of y from the other equation. So I'm putting one equation into the other. So I'm going to replace the y for negative 5x plus 3 equals 2x minus 4. And then I'm going to move the x and solve just like a regular equation. So here we go. Subtract 2x, negative 7x plus 3 equals negative 4. Subtract 3 on both sides. We get negative 7x equals to negative 7. Therefore, x is equal to positive 1. I've got my x value, which is step 3. Now I'm going to solve for the other equation. You can plug it into the first one or the second one, but the second one is actually more convenient because y is already by itself. So we're going to go y equals 2 times 1 minus 4. So 2 times 1 is 2, minus 4 is negative 2. So final answer is 1 comma negative 2. Now for our second example, same idea. The only difference here is we only have one equation solved for y. So I'm going to take that expression, 2x minus 5, and I'm going to substitute it into the y value of the other equation. So I'm putting the second equation into the first equation. So I have 3x plus 2. I'm substituting the y value for the expression negative 2x minus 5. From here on out, it's just solving a multi-step equation. So I'm just going to go ahead and go through that. Combine like terms. Add the 10. And divide by negative 1. And we get positive 2. Now that we have our x value, we're going to find our y value. In this case, easiest to use the second equation. So we have y equals negative 2 times 2 minus 5. And negative 2 times 2 is negative 4 minus 5, which gives us negative 9. All right, so that's the general idea of using substitution. Now we're going to go ahead. Let's cancel all this stuff that's popping up. Hold on, give me 1 second.